Alright, this video is for Unit 3, Lesson 6, which is taking everything that we've done now with quadrilaterals and triangles and using that in the coordinate plane to decide what kind of shape you are working with given a set of points. So we'll talk about the properties of quadrilaterals one more time and how to decide if something is a certain type of quadrilateral. Often we're given a set of points, and if we're given 4 points, well, okay, that tells us there's 4 sides, but we know now, right, we could be working with a parallelogram or a rectangle or a rhombus or, some other special shape. And knowing that it is that special shape is helpful because then we know that it has certain properties. Okay, so what we're going to do basically is we're going to look at the shape, we're going to graph it, and then we're going to make an educated guess based on what we see. We don't measure with our eyes, but if we look and we say, well, that looks like it might be a right angle, well, then we confirm that. That's all. Or if we say, well, it looks like those sides might be the same, okay, we'll use distance formula, right, to confirm that that's true. So you're not measuring with your eyes, but your eyes lead you in a direction, and then you confirm it with the math. Okay, and it'll be easier just to show some examples. Right. The ways that we're going to decide if something is a parallelogram, there's a few different ways to do it. Okay, we could check if the slopes of the sides, the opposite sides, are the same. Because if they are, that would mean they're parallel to each other. Remember, a parallelogram is 2 sets of parallel sides. We could check if opposite sides are congruent. We could also check if the diagonals bisect. And usually that's going to be the easiest way to do it because you just need to calculate midpoints. You can do it the other ways, it just takes a little bit more work. We will decide if something is a rhombus if, 1, it's a parallelogram, and 2, if the diagonals are at a right angle. That is one way to do it. The other way to do it is to show all sides the same length. Now, I don't care which way you go about it. I think it's going to be easiest, less work usually to show this. But if you want to go ahead and calculate the distance formula, if you can show all 4 sides are the same, then that also proves it's a rhombus. Okay, we can show if it's we can prove it's a rectangle if it's a parallelogram with all right angles. And the way we'll do that is we'll check if the sides are perpendicular to one another. The other way we can do it is if the diagonals are congruent. A square, that takes a little more work. You need to show all sides are the same and all angles are 90. That'd be one way. Or you could show that the diagonals are the same length and bisect at right angles. So that we'll do an example with a square, but there's quite a few ways you could go about that. Okay, a kite, if you have 2 sets of congruent sides that are adjacent. Okay, so in other words, right, 2 that are the same and then 2 that are the same but not opposite each other, right? Not like in a parallelogram where the opposite sides are congruent, but the ones next to each other. And a trapezoid is if you have exactly 1 set of parallel sides. Okay, so it's a lot to keep straight. If you can't keep all that straight, then the next best thing to do would be to just show everything. So find all the lengths of the sides, all the slopes, because that's usually enough to decide like, okay, this thing's a rectangle or a square or whatever. So you can kind of brute force it as well. And we'll go through some examples. Um, Sometimes you'll be given the picture. Okay, here they're giving the coordinates, they're also just drawing it for you. And you're being asked to determine what type of parallelogram this would be. Okay, so you know, if it wasn't plotted already, you would do that, but looking at it in the coordinate plane, certainly it's a four-sided figure. The question is, you know, what special kind of four-sided figure is this? And you know, our initial instinct would be like, maybe this thing's a rectangle. Well, so how can we show that? A couple different ways, and I'll go through a couple different approaches, but first thing you could do is show if the diagonals are the same. Are the diagonals congruent? Well, so the diagonal would be EU, right, and TN. Those would be the two, and you would use the distance formula to do that. Okay, so the coordinates of E, right, they're all given up here, so we'll do the x coordinate, -6, and then U is 4, so -6 minus 4 squared plus, and then 7 minus 2 squared. All right, and then clean that up. So that's 10. This is going to be -10 squared, which is positive 100. And then this will be 5 squared, which is 25. So that's root 125. Now just leave it like that. Don't bother to reduce it, because you just need to know what the number is, right? You need to see if it's the same as the other one. You don't need to put this into simplest radical form or anything like that, or get a decimal. Just go right to doing Tn. Okay, so T is 0 plus 2, really, when we subtract. And then 10, really plus 1 when we subtract. Okay, so that's going to give me 2 squared is 4, 11 squared is 121, and so sure enough, right, these are the same number. So the diagonals are congruent, right? Therefore, it's a rectangle. One problem, though, is just because it's a rectangle, well, that could also mean it's a square, right? Some rectangles are also squares, so we need to show that it is not a square. Well, how can we show that? Well, you know, fastest way would be to show that two of the sides are different. So like show TE, you know, find the distance, and find, you know, TU, find the distance there. TE is going to be, let's see, 0 plus 6, so it'd be 6 squared, plus, I'm just kind of doing the math out in my head here, so 17 squared, sorry, 3 squared rather. And then, you know, we could also do TU would be 0 minus 4, so 4 squared is this, and then 8 squared. Okay, and when you do that out, you can see these are going to be different. 36 plus 9 is 45, and 16 plus 64, that's definitely not 45, that's 80. Okay, these are not congruent, and so that tells you it is not a square. Okay, so you need to name it as specifically as you possibly can, ruling out all possibilities. So in other words, if you show that it is a parallelogram, you need to then show it is not a rhombus and not a rectangle. And of course, as soon as it's not a rhombus, then it cannot be a square, and as soon as it's not a rectangle, then it cannot be a square. Right? Sometimes this flow chart is helpful for students sometimes. Right? Some rhombuses are also squares. Some parallelograms are also rhombuses. Every square is a rectangle, right? But not the other way around. Okay. The other way that you could have done this would have been to show that it had all right angles. Now that would require you to find the slopes of all the sides, but let's just look at like, you know, the slope of ET. And you can, you know, just use the graph if you want, and count. You don't have to do slope formula. So oops, let me use red pen. There we go. You know, up 1, 2, 3, over 1, 2, 3, 4, 5, 6. So up 3 over 6. And then, check the slope of TU. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so you can see the slope of ET was 3 over 6, better known as 1/2, and the slope of TU was -8 over 4, better known as -2. Well, those are opposite reciprocals, so that means, right, those lines are perpendicular. Now you would also need to do that for EN and NU, but if you did go through that, you would find that those also give you slopes of 1/2 and -2. And so these are all different approaches. You could have gone about this way, would have been fine, or looking at the diagonals. Either way, though, you still need to show that it's not a square in the end. And the easiest way to do that is to show the sides are different. Now, sometimes they give you a little more information. Okay, something like this. Is this quadrilateral a parallelogram? And instead of giving you a set of points, what they've done is they've given you a set of equations. And so we are looking, at this shape. Let me use this black marker for a sec. Right, the shape bounded by these 4 lines. This shape here. Is it a parallelogram? Well, yeah, it has to be, because one line has a slope of 2 and another line has a slope of 2, right? So those are the same slope. And that means these are parallel. But also, right, this has a slope of -1 and this has a slope of -1. Okay, so these are also parallel to each other. If 2 lines have the same slope, then we know they're parallel, and therefore we have 2 sets of parallel sides. So you would say, yes, it is 2 sets of parallel sides. You can abbreviate, you can use the symbol for parallel, that's fine. Now here it simply asks, is it a parallelogram? So you're done. It's not asking you what type of parallelogram it is. Okay, another example. Looking at this one, you would say, all right, kind of looks like a kite to me. So probably the easiest thing to do would be to go ahead and find all of the distances, right? To check the lengths of all sides. Okay, so you would go ahead and do that. RS and RV. If it is a kite, these are supposed to be congruent, and ST and VT. So you may want to pause the video at this point and just practice your distance formula, and I'll catch up with you. So RS is going to be 7 squared and plus 1 squared. And then RV is going to be 1 squared plus 7 squared. Just looking at it, and you can see that these are obviously going to be the same. You'll get 49 plus 1 is square root of 50 and square root of 50. Okay, which tells you those are congruent. And now you would check ST. Let's see, that's going to be 3 squared plus 9 squared, and VT is going to be 9 squared plus 3 squared. And again, you can see that those are going to be congruent. 81 plus 9 is root 90. Okay, and so those are the same, and so therefore it must be a kite. Okay, that's enough information. If you can show that this is congruent to this, and this is congruent to this, then it must be a kite. Okay, there's no other possibility. So that's enough, and you don't have to show anything else, because once it is a kite, it couldn't be a square or a, the only other thing it might be would be a rhombus, but that would only be if all the sides were the same, which you've already shown they're not. Okay, so you let your eyes give you an initial guess, and then you check to confirm your guess. Okay, looking at this, My initial guess would be that this thing is a trapezoid, just looking at it. In order to be a trapezoid, that would have to mean one of the sides is parallel, one of the sets of sides rather, and the other is not. So we would need to show that. So what I would do is I would find the slope of BC and the slope of AD, and hopefully those are the same. If they are, then we know those are parallel. Okay, but then I need to also confirm that the slope of AB and the slope of CD are not the same. Because if they were, then I would have a parallelogram, not a trapezoid. Okay, the slope of BC, looking at it, let's see, it's rise over run. So it's going down 6 and over by 3. Okay, that reduces to -2. I'm just looking at the graph paper to do this. You could use the formula if you want. AD, let's see, goes down from 3 to -5. That's -8. And over by 2, or sorry, by 4, from -3 to 1, and sure enough, that gives us -2. Those are equal, and therefore those lines are parallel. Okay, now again, your eyes can kind of tell you that A, B, and C, D are not parallel, but we don't trust our eyes. We only trust the math. So doing the slope of AB, okay, we're going up. Let's see, by 2. And over by 4, so that's a half. And then CD, we're going up by 4, and then over by 3. And so, yeah, we can see that those are not the same, and so they are not parallel. And so, therefore, this thing must be a trapezoid. Okay, you have exactly one pair of parallel sides, guaranteed to be a trapezoid. Okay, in the previous examples, we've graphed it for you. Normally, we would ask you to plot it and decide for yourself. So I will go ahead and do that. A is -1, 4. You're really not going to be able to get these without drawing it. 2, 6, or at least I certainly can't. 5, 4 would be C. It's helpful to label everything as you go, and D, 2, 2. All right, connect your shape. My initial reaction would be that this thing is a rhombus because it looks like all the sides are the same. So that's going to be my initial guess. Now, if it is a rhombus, the easiest thing to do would be just to check the distances of all the sides. So yeah, you got to set up distance formula a bunch of times. But again, with graph paper, this isn't really too bad. You don't actually have to do x2 minus x1. You don't have to do that every time. Because think about what that really means. When you write that out, what you're doing is you're simply finding the difference between the coordinates, which is a lot like when you do slope. So in other words, going over to this graph here, let's just say you're trying to find the slope of, or the distance of this line. Well, you can take the difference in the x coordinates is 2, or the y coordinates is 2, and the difference in the x coordinates is 3. And so when you're setting up your distance formula, you could simply do 2 squared plus 3 squared if you wanted to. And that comes back from when we used to do Pythagorean theorem to do this. And so that's going to give you 9 plus 4 is 13. Okay, go ahead and do BC. If you look at BC, you can see it's the same thing. You're going over 3 and down 2. And you're going to get the same thing. And then sure enough, for AD and also for DC, looking at your graph, you're going to go down 2 and over 3. And down 2 and over 3, or up 2 and over 3, whichever way you see it. And sure enough, they're all root 13. So it must be a rhombus, therefore, because they're all the same length. The question now is, could it be a square? Right, so if something is a rhombus, then we need to rule out that it is not also a square. Fastest way to do that would be to show that something is not a right angle. So I'm going to show the slope of AB is up 2 over 3, and the slope of BC is down 2 over 3. Those are not opposite reciprocals. So therefore they are not perpendicular, and therefore it is not a square. And thus it must only be a rhombus. Okay, so this is the idea. You are given a set of points. You need to decide what it is. If you're not sure, then the best thing to do is simply find everything. Find all the distances, all the slopes, because then you can decide if things are the same length, and you can decide if things are parallel or perpendicular. And from there, usually you're able to determine what kind of shape it is. By the way, if it is nothing, then you simply say that it is a quadrilateral. Okay, so that would be like a four-sided shape, kind of like this, where there's just nothing special going on. These are slightly different slopes. These are slightly different slopes. They're all different lengths. That's not going to happen very often, but if it ever does, you simply say it is a quadrilateral and nothing else. All right, that is the lesson for today. Go ahead and attempt Unit 3, Lesson 6 assignment. If you have any questions, let me know. Thank you.